Stanford University.
Okay, well, welcome to lecture number 8 of CS193P, fall of 2017. Today it's all about animation. It's going to continue a little bit of what we talked about last time. There's 3 kinds of animation I'm going to talk about today. The first is UI view property animation, and it's exactly what it sounds like. You can animate these yellow properties on your view. This is really the only things you can animate using this UI view property animation mechanism. But it's pretty powerful, right? You've got the frame and center that's animating the position of the view. You've got the bounds, which will animate the size of the view, although only in a transient way because it's the frame that determines where you are. And so if you're going to make it larger and it occupies more space in super view, you have to set the frame. The transform, which is super powerful, we saw that with a card where we rotated the corners upside down, so you can do rotation. You could also do scaling with that. In fact, that's probably a better way to do scaling than trying to muck with your bounds. And then opacity, another good one, fading views in and out, appearing, disappearing. And background color, we almost never do that, but you could do that. So the way this works is with a class called UI View Property Animator, not surprisingly, and it works with closures, okay? And basically the way it works is you set a bunch of things on your property animator, your view property animator, to say what kind of animation you want, how long it's going to take, what curve of going through the process quickly or slowly it's going to do, if you want to delay before you start, all these kinds of things. You set that up, and then you give it a closure, and inside that closure is just code that modifies these properties. Okay? So that's it. Then it will animate those changes that you asked for in the fashion that you described. Okay, so this is a super simple way to animate these properties in the view. Okay, so let's take a look at what it looks like to call it. Now, I'm not even going to scratch the surface of UI View Property Animator's power. It's amazing. You can create these animations. You can scrub them backwards and forwards. You can have them auto-repeat and reverse, do all these things. I'm just going to talk about kind of the simplest way to use it, which is this class method, running property animator. Okay, this thing creates a property animator that will immediately start running. Okay, now the arguments to it are very simple. The first one with duration is just how long this animation is going to take to happen. So you can make it a 1-second animation or a 10 seconds, totally up to you. Delay is how long to wait before you start this animation. Why would you want to delay the starting of an animation? Well, maybe you got some other animation going on. You want to wait, for some time for it to finish, although there's ways to chain animations too, so that when one finishes, you start another one, but you might delay for that reason. Then options I'll talk about later, just the various options, how you want the animation to run. And then the all-important closure right there, animations. It takes no arguments, returns no arguments, this closure, and you just put the code that's going to modify those properties in there, okay? And then there's a completion closure as well. This will get called when the animation actually finishes running. And that completion one has an argument there, which is position. The position's either the start, because you might be running this animation backwards, believe it or not, or it's the end, so the animation got all the way to the end, or if the animation got interrupted in the middle, then the position will be called current, .current. This is an enum right here, .current. Why would an animation get interrupted in the middle? You start another animation that animates one of the same properties, okay? Then that animation wins and it starts taking over, okay? Now you can have multiple of these property animators going side by side, all modifying different properties, but once one starts to pick on the properties of another one, the later one starts to win and take over, okay? And then this one will stop, go to it'll say it's complete with the current position, okay? Now, there's something very important to understand conceptually about how animations work, okay? And I'm going to show you an example of calling this running property animator. That closure that you pass to it gets executed immediately, okay? It does not take 5 seconds or 10 seconds or however long for that closure to execute. It executes immediately and takes effect immediately. So the animation is only what the user is seeing, okay? So the user is seeing your animation happen over 5 or 10 seconds, but actually it happened the instant you started the animation. Okay, so there's a difference going on here. There's the reality, which is in your code. That all happens instantly. Then there's the presentation of it that happens to the user. That's what happens over time. So this can be confusing because you might have an animation that you set to go off for 2 seconds and it starts running for 2 seconds, and you know, you're thinking, oh yeah, my animation, when it's done, my frame or my center or my alpha will be changed. But no, the instant you started the animator, that got that stuff changed, okay? So you have to think about these two time frames. This is what makes animation somewhat difficult, is thinking about what we call the model, but it has nothing to do with model view controller, but you know, the actual reality in your code, and then the presentation, which is a different thing, is what the user's seeing, all right? So here I'm going to take a view that's fully opaque, and I'm going to fade it out, and then when it's gone, I'm going to remove it from its super view. Okay, so this is basically make a view disappear from the screen animation. So first I'm just checking to make sure that I'm fully opaque, if my view alpha is 1. Then I'm calling the animator here. This animation is going to take 3 seconds to fade out, and it's not going to start until 2 seconds from now. That's what the first two arguments mean. Then I picked one option, just for fun, which is allow user interaction, which means that as it's fading out, gestures and stuff will still work on it, okay? Otherwise, if you don't specify this, then as animation is happening, this kind of animation, you won't be able to, you know, tap on things or whatever. Then here's my animations. My animation is just setting my transparency to 0, fully transparent, right? So that happens immediately when I call this method. This method, running property animator, returns immediately, having executed that closure immediately. Okay, and then I have a completion. If this thing gets to the end without being interrupted, in other words, I do fade all the way out to 0, then I'm going to remove myself from my super view. That's what this little completion closure is all about. Okay, but notice I put print alpha equals whatever. That's going to say alpha equals 0. Do you see why? Because even though it's going to take 5 seconds for that alpha to go to 0, it goes to 0 immediately because I executed this animation. Okay? So I've said that. I'm sure you're like, oh yeah, makes sense. But until you start coding it up, you're going to be like, whoa, oh, that's right. I already changed that. Okay? It just hasn't appeared on screen. So you have to get a little bit used to that. What are some of the options that you can do when you're doing these animations? The first one, begin from current state, is if you're animating some property and then you start another animation that animates the same property. Does it start from the real value of the property, which is what it got set to, like alpha equals 0? So does it jump to transparent and start animating from there? Or does it pick up from wherever that other animation was? This is really, do you use the state of alpha that is being animated, or do you use the real state of alpha, which is what's in the code, which, using our previous slide, would be 0. Okay, so this is kind of like picking up or just using the real version. We do this quite a bit if we have overlapping animations that are doing the same property by 2 different animations. What else we got in there? We got repeat and auto reverse, so you can have animations that go forwards and backwards and forwards and backwards. Okay, it's kind of in a loop. That's kind of fun. Down at the bottom, you see these curves, curve, ease in, ease out, for example, third from the bottom. That's just saying when you move the thing, does it move linearly? That's curve linear, which would be like it would just move like that. Or does it kind of ease into moving slowly, then pick up speed, and then slow down at the end? Now, why would you want it to do that? Well, things that move like very linearly, okay, feel kind of robotic and mechanical. Things that ease in and then ease out feel a little more like someone picked them up and moved them over and put them down. You see? So it's just kind of more natural movement. So like for moving things, you almost always want curve, ease in, ease out. But other ones, like maybe fading out, alpha, maybe you don't need that. You can just linearly fade out. Okay? So that's it for view animation. Super, super easy. You can only animate those properties. It's super easy to do. And again, I only scratched the surface. I showed you one method in UI View Property Animator. It has dozens of methods, okay? Lots of capability in there. All right, so let's talk about a totally different kind of animation now. This is animating an entire view change. So you've got a view, and it's going to completely change the way it looks, and you want to animate that in some ways. And there's limited ways to do that. The classic example of this is a playing card. When a playing card is face down, it looks like the Stanford logo, or, you know, it's the back of a card. When it's face up, it's got pips and corners and all that stuff. Okay, well, when I want to flip my card over, I could just change it immediately and it would just change back and forth starkly. But this allows me to actually flip it over, like a 3D looking flip. Okay? And you can also cross-dissolve from one thing to another. Those are the two major things you can do here. There's curl up from the bottom too, which makes it like it's curling up and you're looking at a piece of paper behind it, and that's the new version, but that's only for views that fill the whole screen. Okay, that's not for, it doesn't really work if it's a view inside another view. It kind of doesn't feel right. Okay, so this is for transitioning, just smoothing out or animating a complete change to a view. Playing card being the classic example. Here's how you would call it. You use this method in UI view. It's a class method called transition with the view. And you give, again, duration, you give the options, same options as we had before, also with some options like transition flip from left, which means flip this thing from the left edge. You can also have flip from top, flip from bottom, cross dissolve, those kind of things. And now in the animation block, you're not limited to just changing view properties. You can change anything you want that's going to make that thing look different. And so then what the animation system does is it draws your view before this closure, then it executes this closure, draws the view after, and then it just flips it over or cross dissolves it. You see what's going on here? So this is kind of a simple animator for big changes. Playing card is a great example of that, and we'll see that in the demo I'm going to do. All right, so that's number 2. Here's number 3. Okay, this one's a little more powerful, a little more complicated. Dynamic animation. It's a little different approach to animation. Here we're going to set up physics attributes on our views and then just tell them to go do what they do. So we're talking physics like density, friction, gravity, stuff like that. You put them on there and then they just start moving because physics, it works, okay? So let's talk about how you make this happen. There's 3 steps to making it happen. First, you need an animator. This is just the thing that drives the animation, okay? It's an instance of a class called UI Dynamic Animator. It only takes one argument in its initializer, which is the view that is going to be the reference coordinate system for all animation that's going on. And the only requirement for this view can be any view in your app. It just has to be a super view, or a super view of a super view, or a super view of a super view. It has to be at the top of the view hierarchy of all the views that the animator is going to animate. But those views don't all have to be in the same view. They could be in subviews of other views, as long as they all or eventually have this view, the reference view, as a super view. So, you know, a lot of times people want to make their whole view controller's view, and that's what I'm going to do in my demo, be a reference view, because I don't have any other views. But like in your assignment, you might just make your view that contains your cards be your reference view, because you're only going to animate the cards. And so you don't need to go higher level. All right, and in fact, it's better to stay lower down because it can be more object-oriented to have that animation code down where it's actually happening instead of putting everything up in your controller. But I will say, by the way, especially when you see me do demos which are really lightweight, there is a tendency you probably have as beginning iOS people to put everything in your view controller when maybe it wants to be down level in a view, a custom view. So just food for thought there. Think about what level things want to be at. All right, so number 1 is create the animator. Number 2 is to create behaviors. So this is describing how the things in this view behave. And so we're talking about gravity and whether things collide with each other, stuff like that. Okay, those are behaviors. And you add the behaviors to the animator. So animator has an add behavior method. You call it after creating a behavior, and you just add it. Now, as soon as you add that behavior, okay, that animator will start enforcing that behavior, whatever it is, gravity or collisions or whatever. But there's no items yet that are being affected by the behaviors, so step 3 is to add items to the behaviors. So it's create an animator, add behaviors to the animator, now add items to the behavior. The instant you add an item to a behavior, it will start being affected by that behavior, assuming it's in an animator. And UI views are the items here, but actually there's not UI views, it's any object that implements the protocol UI dynamic item, which doesn't have to be a view. I'm going to show you that protocol in a second. But UI views are 99% of the time what we pass as items to these behaviors. So if I say gravity add item 1, item 1 will immediately start feeling the pull of gravity. If I say collider add item 1, immediately item 1 will start colliding with everything else that is added as an item in the collider. Okay? So all this, you don't say go, it's just like as soon as you add an item, it starts being affected by that behavior. And if you remove an item, it instantly stops being affected by that behavior. Okay? So here's that UI dynamic item protocol that Vue implements. Vue actually implemented 3 of them automatically. It had already had a bound, center, and transform. Okay? So it automatically implemented those. And then the other 2 are just really simple things having to do with collision. I'm not even going to talk about those. But you can see by what's in the dynamic item protocol what the animation system is able to animate. It's able to animate the size through the bounds. It's able to animate the position through the center, and it's able to animate the transform, so it can rotate and scale and, you know, do anything it wants pretty much in that front. And it tends to mostly use transform and center to do its animation. Okay, the bounds, if you notice, is read only. So the bounds is just for the views. They can obviously look at their own bounds when they're drawing and stuff. The animator doesn't actually change the bounds, okay, as it goes. It's mostly doing center and transform. By the way, if you give an object to the animator by making a behavior operate on it, really the animator kind of owns it. It owns center and transform as it's going to change them around. So if you wanted to change the center or transform of a view you already gave to a behavior, then you have to call this method in your dynamic animator, which is update the item to the current state. In other words, I changed the center or the transform. Please, Mr. Animator, take that. And so the animator would take that state, move the object, change its transform, and then start behaving on it again. Okay? Keep going forward, behaving from there. All right, so let's talk about some of the behaviors you can have. I mentioned gravity. Gravity is an easy one. By default, gravity is down, meaning down towards the home button or the bottom of the device, like on iPhone 10. It's away from the face recognition stuff at the top. And the magnitude is, we sometimes call it G, but it's not really G. It's the magnitude of 1.0 is 1,000 points per second per second. Okay, everyone knows what gravity is, right? It's an acceleration, 9.8 meters per second squared. So this is 1,000 points per second per second. Now what's incredible is 1,000 points per second feels a lot like 9.8 meters per second squared. In other words, if I put an object at the top of my screen and add it to a behavior with that gravity, it falls at about the same rate as a real life object would fall. It's amazing that that round number ends up being like that. But it is. And then also, gravity doesn't have to be down. You can make gravity go up, okay, or off to the right, or anywhere you want, okay? So you can completely control what's going on with gravity. Attachment behavior, really cool one. It's essentially taking, think of it as like an iron bar or a bar between either two items or between an item and a fixed point, all right? And that bar keeps those two items connected even as all the other behaviors work on it. So imagine you had two things connected with a detachment behavior, so they're behaving as if they're attached to each other, and they start to fall because they're both being operated on by gravity, okay? Then let's say one of them collides with something, okay? That bar is going to make it so the other one, which didn't collide, is going to swing like a pendulum, you see? Because this one came down, it collided, and this one kept on going, but the bar keeps them together. And same thing if you attached it to a fixed point and then you turn on gravity, it'll start to fall down, but then when it gets to the bottom, it'll start swinging like a pendulum, okay? And then eventually gravity will pull it so that it's straight down. Do you see what I'm saying there? So attachments, awesome, cool little things. Another thing that's cool about them is you can change the length of this bar while the animation's happening. Okay, so it's animating, things are falling, bouncing off things, colliding with things, they're attached, and you can make the bar get closer together or farther apart. You can also make the bar kind of springy with a certain amount of damping so that things hit something and then they'll come together and then come back up to make their attachment be the right distance. It's pretty cool behavior. Then there's collision behavior. This is probably the most common behavior. Okay, this is objects, UI views bouncing into each other or bouncing off Bezier paths, basically, in the background. And you set this up just by adding any fixed boundaries you want as Bezier paths, usually, and then adding items. And you can control whether the items bounce off each other or only off these boundaries, these Bezier paths that you set up. All these Bezier paths are in the reference views coordinate system, by the way. They're not actually drawn or anything. They're just conceptually boundaries in the space. And there's a really cool var in there. This thing, second from the bottom there, translates reference bounds into boundary. If you set that to true on a collision behavior, then your reference view's outer edges will become a boundary, which is common because you got things bouncing around in your reference view, they'll stay mostly inside. Now, one thing about collision boundaries, a lot of people think, oh, if I put my reference bounds as a collision boundary, then no object will ever get out. Okay, no, it will never escape. But that's not true, because items can, for example, move so fast that in one animation frame, they move from being on one side of the boundary to the other, and then they just fly off into outer space. They're gone forever. Okay, so collision boundaries, they only check for collisions on each frame of the animation, and so they're not a lockdown guarantee, keep things inside if you put a collision boundary around everything. Now, collision boundaries also have a delegate. Okay, their delegate allows you to find out when collisions happen. So if you set something to be a collision delegate, you'll get these methods like collision behavior began contact for some dynamic item with a boundary and an identifier with a name. By the way, notice the boundary identifiers are of type NS copying. Okay, that's a really weird old Objective-C thing. That just means that they're either an NS number or an NS string. And so you can use as to turn them into a string or a double or an int, because we know that NS number and NS string can be like automatically as'd to their Swift counterparts there. Okay? So collisions are cool. Snap behavior, also very common. This is when you're using the dynamic animation system, how you move something. Okay? So you want to move something someplace else, you're not doing view property animation here, you're using dynamic animation, so you say snap to this point. It's a little better than the view property one because when it snaps there, it doesn't just jump right there or even ease out and ease in there. It actually gets there, and when it's there, imagine it has 4 springs on the corner, so it kind of comes in and vibrates a little. Okay, so it feels even more natural flying across the screen and stopping. So you'll probably use the snap behavior in your homework because you have to throw matched cards into a discard pile. You're probably going to use snap to throw them out there because you're going to be doing dynamic animation with them otherwise. Then there's push behavior. Okay, push behavior just pushes an object. And it can either constantly push it, okay, or it can just push it once, like punch it. And this is an interesting one. You can specify the angle and the magnitude of the push. The instantaneous one is kind of interesting because think about it. This is a behavior that's added to an animator, and this behavior only fires once if it's instantaneous. And then it's just sitting there doing nothing forever. So it's just kind of cruft. So it'd be nice if there was a way that we could add a push behavior and say, after you fired, please delete yourself because you've already done your work. And I'm going to show you how to do that, but it's going to cost it's going to require me to teach you a little bit more about closures, which I'll do in a little bit. Okay. Another one is a UI dynamic item behavior. This is like a meta behavior. Okay. So this is a behavior where you specify things like friction and elasticity and whether you allow rotation of the view as it's bouncing off of things. And this affects how all the other behaviors work, right? If you add more friction, then obviously gravity pulls on things, they move slower because they have friction, etc. You can also ask the UI dynamic item behavior about all of its items, things like what's your current velocity? Okay, how fast are you moving across the screen? Or even how fast are you spinning if you happen to be spinning? How fast is that happening? So UI dynamic item behavior, we almost always have all our items in a UI dynamic item behavior because we want to be able to set these various things about them. Then there's UI dynamic behavior, which is the superclass of all of these behaviors, collision behavior, gravity behavior, all these things. Now, you could subclass this and try and write your own behavior, but writing a gravity behavior is pretty hard. A lot of math involved there, okay, trying to make that work. But that's not why you use a subclass of UI dynamic behavior. What you do with UI dynamic behavior is you collect other behaviors, like collisions and gravity and all this stuff, into one behavior. So that you have one behavior that you add your items to, and it's got all these children behaviors that are making it behave in all this way. And we're going to do this in the demo as well. And the way you do this is you call add child behavior on yourself if you're a UI dynamic behavior subclass, and it now causes that behavior to be your behavior. Okay? So very simple. UI dynamic behavior also has a var in it called dynamic animator. That is the animator you are currently being animated by, if any. Okay? So you can look at this to find out, am I currently being animated, this behavior, or is it not being animated? And if it is being animated, who by? And it'll even send you a message, will move to animator when you switch to a different animator, usually when you go from not being animated to being animated, or vice versa. All right? Now, UI dynamic behavior has another awesome var that you inherit when you create a subclass or when these subclasses are created, which is action. So action is a closure, takes no arguments, returns no arguments. This closure gets executed every time this UI dynamic behavior acts. Okay, so like a push behavior that's instantaneous, this gets called once, okay, because only once does it act on object. But a collision behavior is kind of always acting on the object, or gravity behavior, always. So this thing is getting called a lot. So never put any code in here that takes a long time to execute, because it'll slow your animation rate way down, because these things are being called all the time, these action closures right here. But they can be kind of useful. For example, you might want to check in here, has my view left the building, right? You could look at whatever the items that this behavior is acting on, and did it cause this thing to go outside the reference bounds even, or whatever, so that I have to either put it back or maybe destroy it or something like that. So again, it only takes a couple of lines of code to check the bounds of your item against the reference bounds and see if anything's happened. So that'd be okay to put in an action. Now we're going to use this action thing in a second to fix that push behavior problem too. All right? Finally, I'm going to talk about stasis of the animator. Really, most of the time we design these animation mechanisms with all the gravity and collision boundaries and physics and all that stuff. We design it in a way that we expect it to come to a stop. Okay? And then maybe a push happens and it goes back active again, and then eventually it comes to a stop. Most of the time, it's not required. You could have a thing just constantly going all the time, but usually you push or whatever and it comes to a stop. And so you can find out when it reaches stasis with the UI dynamic animators delegate, which has these two methods, did pause and will resume. And it'll tell you, I came to stasis, I'm not currently moving anything, and then something happens, it'll say, I'm resuming because I have to move things. Okay? All right. Let's go back and talk about that push behavior thing. So what I really wanted to do something like this. I got this push behavior, right? I set its magnitude and its angle, but I really want that push behavior to get thrown away as soon as it pushes, because it's instantaneous. You see here, my thing here is an instantaneous push, so it's only going to push once, and then I want it to get thrown away so it doesn't muck up the heap with a totally useless behavior. All right, well, I can do that with this action method, the yellow part right here, so I can just have the push behavior's action. All behaviors inherit this action closure, and inside the closure I can ask the push behavior's dynamic animator, please remove me. Okay, remove behavior, the push behavior itself. Okay. So that's cool, right? Solves the problem. Well, yeah, but red on the slides, this creates a memory cycle. Okay? So we're going to talk a little bit about this memory cycle that this creates. And the bottom line here is that the push behavior is pointing to that closure is pointing back to the push behavior. So both of them have a pointer to something them in the heap. And so they're both being kept in the heap. All right, so for me to tell you how we're going to fix that memory cycle, I'm going to have to take an aside here and go back and teach you a little bit more about closures. Hopefully you've read about this in your homework assignment, but here we go. You can define, when you have a closure, you can define some local variables. Fun little local variables. You put a little square brackets with these local variables in there right before your in of your closure, and you can define any variables you want, and you can set them to have some initial value. So here I have variables x and y, and I can use an x and y inside my closure, and they'll have whatever value I set there. It doesn't seem like it's of very much use, and you're right, it's not, because of course I could use some instance of a class, or I could just type hello inside my closure. Why do I need to have silly little variables there? Well, the reason they're not so silly is because they can be declared weak. Okay? These x and y are different variables. They're local variables just for the closure. And if you were to declare one of them weak, then it now becomes an optional, first of all, because we know all weak variables, they don't keep things in the heap, and they also have to be weak because if the thing they're pointing to goes out of the heap, they get set to nil, right? So I can now use x and y still inside there, but x is now optional and weak. Okay, and you're going to see why that's valuable in a second. I can even declare that those variables be unowned. And if you remember back to the thing when I was talking about memory management, unowned means it's not reference counted. It's like Swift says, okay, it's on you. If you're going to access that thing, it better be in the heap, because if it's not, you're crashing. Okay, that's basically what unowned means. So that means I can use x and y inside the closure. It's not an optional. Don't have to worry about that. But if I use x in there and it's not in the heap, it's going to crash my app. Okay? So why is it valuable to do weak and unowned? Well, because weak and unowned variables, whether they're these little locals or not, don't keep other things in the heap. They're not strong. Okay? They're weak or even unowned. So we can use that to break these memory cycles. So here's another example of a memory cycle that happens all the time. I have a class here, Zerg it's called. It has a var called foo, whose value is a closure. Inside that closure, I've set it to have a value of a closure that calls another function in Zerg, which is bar. Okay, this is a memory cycle. And this is a memory cycle because foo, the closure, is referencing self. Self is keeping the class Zerg, the instance of the class Zerg, in memory. And of course, Zerg is keeping the closure in memory because it has a var that points to it. So they're pointing to each other and keeping each other in memory. So that's bad, okay? You got one pointing to the other points to the other. So how are we going to break this cycle? Well, we're going to use those little local variable hoo-has. So I'm going to create a little local variable. It's weak. I'm going to call it weak self. I'm going to set it equal to self. And then inside, I'm going to say weak self question mark, meaning optional chaining, dot bar. Okay, so now there's nothing inside that closure. No variable in that closure is keeping a strong pointer to self. And so it's not keeping self in the heap. Do you agree? Right? The only pointer it has, and the only thing that's even used inside that closure is weak self. And we know that's weak. Can't keep something in the heap. Now, unfortunately, it's an optional, so I have to optional chain it, but I've broken the cycle. So this is how we break these cycles, using weak little local variables in our closure. By the way, we are allowed to call that weak self self. In other words, it can have exactly the same name as a variable that's in the outer scope. So on this slide, there's two different selves. There's the yellow self, that's a local in the closure, and there's the green self, that's the more global self of the instance of this class. Okay, so it's two different variables. I'm not using the green self inside the closure at all. I'm only using the yellow self, and that one's weak. And in fact, this is so common that you don't even have to say equal self. If you say weak self, it will automatically set it equal to a variable of the same name in the surrounding code. Okay? So this is how we break these cycles. So now let's go back to UI push behavior and look how we would use unowned. All right, so here's my push behavior code. If I take that same thing, that action, and just say unowned push behavior in that, I've broken this cycle. Because now push behavior is no longer managed by the reference accounting system, but push behavior better be in the heap right here, okay? If it doesn't in the heap, we're going to crash. But of course, push behavior is going to be in the heap there. Push behavior couldn't possibly even be executing here if its action could not be executed if it wasn't in the heap. So we're guaranteed that push behavior is going to be there. So this is a classic one where we would do unowned to break the cycle. We could have also done weak there and maybe check to see if it was nil, but it was all unnecessary because we know that's never going to be nil there. It's never going to not be in the heap. Okay, so now I am going to do a demo. It's going to be, we're going to take the playing card thing we did last week, and I'm going to make lots of playing cards, and we're going to put them in motion and have them flipping over and all kinds of fun stuff. Friday, I'm not going to get back to the slide, so let me tell you that Friday we will have a Friday section. It's on source code control, so don't miss that one. That's a good one. That's the thing when we're always not clicking when we create new projects to say, do you want to manage this? You know, connecting your code to GitHub and all that stuff is part of that. Next week, actually I say these, but actually we'll definitely do view controller lifecycle, but I'm probably going to do multi-threading next week, which is an important topic, and then maybe some miscellaneous other UI things like scroll view, text field, things like that. Probably do table view and collection view and drag and drop even the week after that. All right, so I am going to show you, I told you I would show you the homework animation thing, so let me do that. Let's go do it here. Where is it? Okay, so again, I'm only going to show you this briefly, but I just want to give you an idea of what you're going to do, okay? Your set app, when it comes up, is going to automatically deal out the cards. You see how I'm dealing out the cards? They're flying out, and they're also flipping when they get there. When I deal new cards, you see, it's smoothly animated to smaller cards, you see, and then dealt out new cards, so you're going to have to do that. Notice I only have diamonds. That's because I want to get closer to the end game faster. This is a debugging thing. Also, any 3 cards are a set right here. So we did this. Now, see what happens when you get a set? They kind of go chaos. They just fly all over the place. But then they eventually collect over here in my discard pile. See, look, watch this again. See them flying all over the place? And notice it's also dealing out new cards to replace them. Eventually, I'll get towards the end here. There won't be any new cards. Notice that my deck nicely disappeared. That's not a required task, but you probably want to do that. And then, of course, as my number gets smaller, you're still doing the chaos animation, and we're rearranging the cards as they go down. Okay? Understand what we're doing? So you're basically doing 3 animations there. One is you're dealing the cards out and flipping them. Another one is when cards match, you're exploding them and then putting them in the discard pile. And then every time the number of cards changes, you're smoothly animating to the new number. You're not jumping them. Okay? That's it. All right, that's it. So the demo for today, which will hopefully help you, let's go here. All right, so the demo that we're going to do today, which will help you with your homework, is to take our card app and put these cards in motion. Now, this is pretty much the same exact card app we had last time, except for the difference is we used to have 1 card in the middle. In this case, I've created 12 cards, and I've used my viewDidLoad to make them be random cards. Okay, I'm just randomly going through, creating these cards, face up, putting the rank and suit on them to create random cards. So let's see what this looks like. All right, there's my random cards. They don't do anything. Okay, I don't have any gestures on them, so I can't tap on them or do anything. So the first thing I want to do is add a tap gesture that flips them over. Okay, and we're going to start this time and flip them over without animation. Then we'll add animation to have them flip. All right, so let's do that. I also heard there was some confusion in office hours about gestures, so this will be a good opportunity to kind of review gestures again. So what I'm going to do here is, first of all, I'm going to start my cards face down instead of face up. And then I'm just going to add a gesture recognizer to them all. Let's make this code big so you can really see what's going on here. All right, so I'm going to add gesture recognizer, oops. Got to add it to a view. So I'm going to add my card view, add gesture recognizer. Hello? How come? Oh, there we go. So I'm going to add a gesture recognizer. The gesture recognizer I'm going to add is a UI tap gesture recognizer. And then just to review what the arguments are to a gesture recognizer, there's the target. This is the object that's going to be sent this action method when the gesture happens. Okay, so I'm going to have the target of this be myself, the view controller, but it could be the view. I could send it to that view as well. And this selector is just hashtag selector, and then inside here you put the name of the method, but only the external names of the arguments. Okay, so for example, I'm going to do flip card, and it's only going to have 1 argument, which is the tap gesture, and I'm going to have it have no external name, so I'm going to do underbar colon. Okay, so this is the name of the method with all the external names and colons in there, but nothing else. Okay, that's all. Very cool with that? Now, this is just complaining because I haven't defined flip card. So now when I create flip card, of course it has to be OBJC. Okay, all these things that do this action thing have to be OBJC. Call it flip card. Has no external name. It's going to be the recognizer. UI tap gesture recognizer. Recognizer, something that makes me type it all in. Okay, see if that gets rid of our warning here. Okay, what's it saying here? Oh, what do we, OBJC func, how about that? It's rebuilding here. Okay, good, that's fixed. Are we over here? Did I forget something here? Okay, good. The code's a little slow to keep up with my typing today. Okay, so now I have this recognizer. Now I want to just find out which card was clicked on and then flip it over. And this is something that I think people are kind of like, how do I do that? And the answer here, of course, I'm going to switch on the recognizer state. We almost always switch on the state. That's like the first thing we do. It's a tap gesture, so I only care about the ended state. All the other states I'm just going to break, right? But if I get a tap, what I want to do is get the card that was tapped on, but I'm in my view controller. Now normally I might have the target have been the view, so it would know that it was itself that got tapped on. But here I'm in the view controller, so I have to find it. Well, it turns out tap gesture recognizer, it knows what view it was tapped on. Remember how I said each of the concrete gestures have information about what happened? Well, one of the things is they know what they were tapped on or whatever. So I can say, for example, if let the chosen card view equal the recognizer's view, Okay, so view is a var in tap gesture recognizer, which is the view that was tapped on. This is maybe the piece some of you didn't get from the doc. As a playing card view. Okay, now why do I need to as playing card view? Because this is just a UI view, of course. Tap gesture recognizer doesn't know anything about playing card view, so I have to make sure that it is in fact a playing card view. It should be, because that's the only thing I added any of these tap gestures to. Then I can take the chosen card view here and have its is face up equal not the chosen card view is face up. So I'm just flipping the card over here, right? Everybody understand that? Okay, so let's go ahead and run and see if this works. Okay, so they're all face down. That's good. See, I changed them all here to be false. So let's click. All right, flips it over. Looking nicely. Okay, but of course we want this to be animated. And we know that that is really easy to do with that UI view transition with view thing. How do we do that? How do we get started on that? Let's just go right here and surround this, put this in a closure that's in a UI view transition. So UI view dot transition. By the way, be careful, there's two different UI view transitions. There's with right here, which is the one we want, and there's from to. The from to is when you're transitioning from one view to a completely different view. And you're going to remove one from the super view and add the other one in as a sub view. So it's a similar thing, but it's like a card where the back of a card was one view and the front of the card is a different view. But here we're transitioning with the same view because we can turn it face up and face down. Here I'll go ahead and spread this out so you can see these arguments a little more clearly. Right. Okay, these arguments, it seems like there's a lot of arguments here, but they're all quite simple. So the view we're flipping is the chosen card view, of course. Right? The duration, I find like a half a second. Maybe a 0.6 of a second is a good amount of time to give it to flip over. Any slower and it feels kind of glacial. Any faster and it's like, whoa, what happened there? It kind of flashes at you, so, you know. Options, here's where we have to say that we want to flip as opposed to cross dissolve or anything. So I'm going to make transition flip from, let's flip from the left. Okay, so we're going to flip from the left. Here's the animations closure. Okay, this is where we're going to do whatever causes the view to look totally different. So in our case, it's this code right here. Right, put this inside here. We don't need that way over there, and then completion, for now, we're not going to do anything when it completes. So I'm just going to take the completion thing completely out of there. We'll put this down here and, oops, Control I, just to make things look a little bit neater there. Okay, everyone got that? So here's our transition with this view, flip from left. We're just going to flip the card over. Let's give it a try. Okay, here we go. Woo! See, and look, see how it kind of shades it a little bit? The shading, the kind of gray, that gives it that 3D effect. It feels a little more like a 3D flip as it flips it over. Okay, so that was easy. So that's transition animation, totally trivial. Let's, we're not really going to make our app here into a concentration app. We're kind of doing a little bit of a UI study here, but what if we wanted this to be like concentration where we're trying to find two matching cards? Okay, but we're going to make ours a little harder. We're going to make it so that when you flip over a card, so here's this card flipped out. If I flip another card, if they don't match, it's going to go like this. Flip, and then immediately flip them back down. So you really are going to have to concentrate. Okay, this really is concentration. Because I go clip and then flip. Didn't match. Oh, you see? So we're going to really watch what we're doing here. So let's add that animation that just turns cards down. Anytime there's two cards up, we're going to turn them down. So to do that, I need a little private var that tells me what my face-up card views are, which is going to be an array of playing card views here. And I'm going to have it be computed. And we know how to use filters and all that stuff. So I'm going to have my face-up cards be my card views. Return. My card views filtered, and the filter is that they are face up, right? Is face up. Let's also make sure that they're not hidden, because I'm going to be hiding cards that are already matched a little bit later, so I just don't forget. We'll make that be hidden. Okay, so now we're able to find out what our face up cards is. So now what I'm going to do is, after this flip over finishes, I'm going to add a completion handler okay, completion, which I didn't have before, but I'm adding it. This one has finished. It doesn't have the position, end, start, current. It just has finished, yes or no, whether this flip finished. Because it doesn't really make sense to move your flip backwards and forwards. It kind of either happens or it doesn't. So inside here, I'm going to do another transition. Okay, so actually I'll just copy and paste. Why not? Copy, paste. And it's perfectly fine to have animations in the completion handlers of other animations. That's perfectly fine. So what am I going to do here? Here I'm going to flip down all the face-up cards if there's two. So let's go and check. If my face-up card views.count equals 2, so I've got 2 face-up cards, then I'm going to flip them all face down using another transition. So let me show you a cool way to do for loops if you have an array. Watch this. Oh, and see here what it's saying? Oh, let's stop and look at this. I got an error here. It says reference property enclosure requires explicit self to make capture semantics explicit. Okay, this is awesome. Swift is saying, wait a second here, bud. You are accessing a var on yourself. That's going to capture yourself. And I want you to type self dot right there so that you realize that you might have a loop here, a memory cycle. So isn't that cool of Swift to make us do that? I really appreciate that Swift does that. Because otherwise it could be really easy to forget, oops, this is self, and then realize, oh, I got a memory cycle. But do we actually have a memory cycle here? No, we don't. Because while this closure does capture self, self does not in any way point to this closure. Okay, it's not part of any var, it's not any part of a dictionary or an array or anything that self has. It's a closure we're giving off to the animation system. So only the animation system has a pointer to it. So there's no cycle here. So there's no reason for us to do any of those weird local variables that are weak or any of that. Okay? All right, so if I have 2 face cards, I'm going to do a for loop of all the face cards, but I'm going to do it like this. Watch this. Face up cards, for each, do a closure. Okay, so I'm going to execute a closure for each of these face-up cards. So that's kind of a cool way to do for loop. And inside there, I'm going to put this here. And of course, in the for each, $0 is each of the things in this. So I'm going to do this flip transition with each of the cards in here. Same thing, same thing. Here it's $0 is face up, and it's not flipped over, it's false. We want them face down. You got all that? Make sense? What do we got here? Let's get rid of this right here also. And what's happening here? $0 is face up. Huh. Okay, anyone see what I'm doing wrong there? Look at my card here. Card view. Maybe I need to do this, card view in. Oops, card view or something like that. That fix it? Yeah, that did. That's interesting. So the $0 I was not able to get the type right there. I don't know why I couldn't infer that. Anyway, okay, so here, if we got 2 cards face up, we're going to flip them both face down. Okay, so let's see if that works. All right, so 1 card face up. We can actually turn this card back face down, by the way. It's face up. Here we go. 2nd card. All right. Works good. Okay. Excellent. Now, what happens if 2 of these cards match like that? These 2 cards, they match. So it shouldn't do that. It shouldn't turn it down. It needs to give us some animation that says, woohoo, you match 2 cards. Okay, so let's come up with that, an animation to that. So the animation I'm going to do when cards match is I'm going to make the cards really big to emphasize that you got a match. Then I'm going to make them really small and have them fade away to nothingness and disappear. Because when cards match, of course, I want to take them away. So that's what we're going to do. Now that's a 2-step animation. The first step is to make them big, and then the second step is to animate them down. And we can do that with the view property animator, of course, because the size of the view and its transparency are animatable properties. And to make it 2-step like that, we'll use the completion thing. It's similar to how we did this, right? We waited till the first one finished, and then we went to do the other one. All right, so how are we going to do that? Well, I need another private var here, actually, which is that's just going to tell me whether the face-up cards match. So I'm going to call that face-up card views match. I think I called that. that what I called it? Yes. Face up card views match. It's a bool. Okay, we're going to calculate that as well. I'm just going to return if our face up card views dot count equals 2, and oops, commented it on the fly. And face up, I'm missing an A there. Face up card views sub 0 dot rank equals face up. And you can kind of see we don't have a model here, so we're kind of looking at these things directly. Again, this is not how you would do this if you were going forward to turn this into a concentration game. You would have a model and all that. I'm really just doing, like I said, kind of a UI case study just to see, what would it look like? And then later, I would go back and do my, actual model or whatever. So this is just a bool that tells us whether the two face-up cards match. So down here, after I've done my first card flip, I'm going to say if myself, of course, face-up card views match. Then here I'm going to do the animation. Otherwise, I'll go on and check just to see if we have two face cards that don't match, and then we'll do that flip down thing. But in here, we're not going to flip them down. We're going to make them big and then make them small. So we're going to use our view property animator here. Very simple to do. We're just going to say UI view property animator dot running property animator. Again, I will try to make this a little easier to see by putting each argument on its own line like that. Okay, so here's the arguments. Properties animators, also very simple. The arguments, seems like there's a lot of them and they're complicated, but they're really not. Okay, so here we're going to make the thing big. So how long do I want it to take to make big? Again, not really more than a second, maybe 0.6 or 0.7. These are blue numbers that I would put in a constant struct and then play with to get my animation to look the way I want. And I'm not going to delay this animation at all. I'm going to start it right off. Really no animation options necessary here. Okay, just going to do the animation. So in here is the closure, and only thing I can change inside here is those view properties. Okay, if I change anything else, it will do it, but it's not going to affect the animation in any way. So what are the animations we want to do here? Well, we want all the face-up cards to get really big. I'm going to do that with the transform. Okay, transform is really easy to make things big or rotate them or whatever. So I'm just going to say my face-up cards views for each again. For each. Oops. And inside this for each, I'm just going to change the properties that I want to change, which is $0.transform equals, and I'm going to get the affine transform identity, which is no rotation, and I'm going to scale it by, let's say, 3 times as big. So this is going to make this view 3 times its normal size. Okay? Let's just do just this part for now. We'll do this completion part in a little bit here. Okay? So I just want to make sure that this is working. So this is going to force us to find a match just to see if it's working, but I'm sure we can do that. Okay, here we go. Need a match. No, 4 and 9. Oh, no, different kind of 4. No good. Oh, there's the 9. Okay, so I'm going to click this card. They're going to match, and hopefully they'll get really big. And then they're going to stop because we're not finished with this animation, but let's see. Woo, okay, worked. That was easy. Now we want the next step of the animation. We want to make it small, and we're going to do its alpha so that it gets small and fades away at the same time. Okay, so we're going to do that with this completion thing that I had commented out. We'll put that back and expand this thing. Remember, this one has the position, not finished, but position, which is either .end, .start, or .current. Okay, and we don't really care what it is because we're not going to have animations that are going to be jumping on top of each other here, so it's not going to be a problem. So here we want to do another property animation, so I'm going to copy and paste this whole thing right here, put it in here. Okay, and what are we doing with this property animation? Very similar to the other one, but instead of the transform being transformed up to 3.0, I'm going to go make it really small, down to 0.1. And at the same time, I'm going to say alpha equals 0, fully transparent. Now, This, remember, this is going to happen immediately. It's going to set to 0, but the user is going to see it over the course of 0.6. And actually, this one might want to be longer, maybe 0.75 or something, because remember, I went from identity transform to 3.0. Now I'm going from 3.0 past identity down to 0.1. So maybe I want to give it a little extra time. You see what I'm saying? To go that extra distance, so it feels like it's coming out and in at about the same time. But again, these are numbers you tweak over time as you're working on stuff. All right, so again, let's just see if this is working. Now I have our completion thing in there. Okay, we got to find another match again. 3, and an 8, and ace. Oh, no, that was ace of clubs and ace of spades. See, oh, there's ace of clubs. Is this ace of clubs? No, ace of spades. Ace of clubs. Okay, ready? Here we go. I'm going to click on this one. Now it should go up and then go down and fade to alpha 0. Let's see. Woo! Perfect. Okay, works just fine. Now, once it goes down like that, we want to remove this card because it no longer can be involved in the matches. So we are going to implement our completion handler right here. And inside the completion handler, we're not going to be doing any view property animation. We're just going to be doing cleanup. For example, I'm going to say here that for all these cards, so we're going to have this for loop again, but not this. For all these cards, I want to set each of them to be is hidden, so I'm going to hide the cards. Now, I'm also going to clean up a little bit, because I really don't like the idea of having these views that are really small transforms, okay, and transparent, sitting around in my view hierarchy, even if they're hidden. So I'm going to go ahead and make the alpha be back to 1, and I'm going to go ahead and make the transform be back to being the identity transform. So it's just a little cleanup. I just don't like to have messy, weird state views lying around. They're hidden though, so it's not really going to hurt anything to have them around there, but it's just, for me, it's just a cleanliness thing to kind of clean up after your animation a little bit. And since it's hidden, none of this is going to show. The fact that I'm making it transparent again and changing its transform, it doesn't matter because this view is now hidden from view. Okay, so that's good. We got that. What's the next thing we need to do? What's the next one we want to do? We want to make it so this game's a little harder. Okay, I've got this game, and it's actually a little harder than our other concentration game was because we have to pay more attention because mismatches, they flip over so fast that if I'm trying to find a match here, oh, whew, got lucky with the match. If I'm trying to find a match, it's harder to do. But I'm going to make it even harder by having these cards be in motion, okay? These cards are just going to be constantly moving around, so I'm going to have to chase after them to flip them over. Okay, and I'm going to do that with our dynamic animator, okay? Because that's the kind of thing a dynamic animator is good. Kind of set them out there and it kind of floats around. All right, so how are we going to do that? Dynamic animator, let's go up here. We're going to start. We're going to do the 3 steps, right? Animator, behaviors, items. So let's start with the animator. I'm going to create a lazy var, which we're going to call animator. It's going to be a UI dynamic animator. And the reference view for it, I'm going to use the reference view constructor here. I'm going to make my self.view, right? The top level view of my view controller. I'm going to make that be my reference view. Again, if you were writing an app that had like subviews and stuff, it might not be the top level. But this is a demo. I don't have any other views, so that's what I kind of have to do. All right, so that's going to be my animator. Great. Now I need behaviors. So I'm going to create another lazy var here. I'm going to call it my collision behavior. It's going to be of type UI collision behavior. And I'm going to initialize this one with a closure. We talked about that in lecture, but we've never actually done it, I don't think. So how do I initialize it with a closure? Really easy. I just create the behavior. I'll create a UI collision behavior here. No arguments to its initializer. Configure it. So the only thing I want to do with this collision behavior is have the edges of my reference view keep my cards in. The only thing the cards are going to bounce off is each other and the edges. So I'm going to do this translates reference bounds into boundary equals true. It's kind of a cheap, quick way to get a collision boundary. Then I'm going to add it to my animator. Add behavior. And I'm going to return the behavior from the closure. This returns it from the closure, which assigns it to this var. And it's all lazy. We see how we use a closure there? Really convenient. Now we have, what do we have here? Oh, add behavior. Behavior. Okay, add the behavior to the animator, all right? So now we have this behavior. We need to do step 3, add items to it. Here's where we're creating all of our card views. Let's just say right here, collision behavior dot add item card view. Now that card view is instantly going to respect that boundary and start bouncing into other cards. But of course, we haven't moved the card. It's not moving, so we need to do that. We're going to do that with a push behavior. So I'm going to let push equal a UI push behavior. Okay? Now push behavior's initializer here takes the items that you want to push. So here I'm just going to push each item in a different direction. So this would only be this one card view right here. Okay? I could create a push behavior that puts all the cards in there, but then they would all get pushed in the same direction. I don't want that. And then the mode, again, can be continuous or, in our case, instantaneous. Okay? We're just going to give the card a push, and then we're done. And since it's instantaneous, we're going to want to clean up after it. So let's give it an angle. So I'm going to give it a push angle, which is a random angle between 0 and 2 pi. This is in radians. So I'm going to say 2 times cgfloat.pi. And it's going to be random. So I'm going to use arc4random. I added a little arc4random to cgfloat as well. Okay? We added it to int, but you already know how to do that. But I added one for float. And then the magnitude, I don't really want to push it 0. So I'm going to do a magnitude of, let's say, at least 1.0, right? But then I'm going to add a certain amount extra, let's say 2.0 arc4random. Okay, so we're going to have the magnitude, and this has to be a CG float, right? This is a double, so we'll go CG float of all this. Oops, CG float 1.0, CG float 2.0. Random, probably don't need both of those CG floats. But anyway, so we'll create a random. So I'm creating a random magnitude between 1 and 3, okay? Pushing it a random amount there. Now I just need to say to the animator, add this behavior, this push behavior. Okay, and as soon as I add it to the animator, it's going to push its items, which is just that one card view. Now, again, we know that this is bad because it's done now and it's never going to get cleaned up. So I'm going to use the pushes action, okay, to remove it from the animator by just saying push, tell me your dynamic animator if you have one, and remove yourself from it. And we know that this causes a memory cycle because this push right here is being kept in memory by this closure. And of course, the push's action is pointing to the closure, so they're keeping each other in memory. So we're going to get rid of this by just saying unowned push. And yes, I could have said weak push and then had an optional chain here and maybe even exclamation point here. But if I'm going to do exclamation point, you might as well make it unowned because you're unwrapping it anyway. Okay? All right, so let's see what happens. So all we did here is we created an animator, a collision behavior, and a push behavior. Let's see what happens. See if it just animates. Woohoo! We did it. Now, I'm not quite getting what I want here, though. One thing is, look how quickly it settles down. It kind of settles down too easily, too quickly. That's going to make it too easy to play this game, okay? I want those cards moving a little more. The other thing is, I don't think I want them rotated. It's kind of fun to have them rotate, actually, but you know, when you flip the card, for example, it doesn't flip along the axis of the drawing. It flips along the axis of the view. So watch this flip. You see how it's kind of flipping around the corner? And maybe that's okay, but I'm just going to decide it's not because I also want to show you how to do dynamic item behavior. The reason that it's slowing down so much is there's not enough elasticity in the collisions. I want those collisions bouncing off and keeping the energy up, okay? So let's fix that, and we do that with another kind of behavior, kind of like our collision behavior. It is a item behavior. It's a UI dynamic item behavior. And I'm going to do that with a closure as well. So we just create the behavior here. Oops, let behavior equal the UI dynamic item behavior. And now we'll just configure this behavior. So I want allows rotation, false. I don't want those things rotating around. I want elasticity. And see, and there's a lot, you're going to have to look in the documentation to see all the incredible things you can do here. But I want elasticity 1.0 means that collisions don't lose any energy or gain energy. If I set this to elasticity 1.1, they would gain a little energy. Those things would start going faster and faster and faster. They would forget it. But if I set it to 0.9, they're going to slow down, not as slow down as much as they are now, but so 1.0 is as kind of as most elasticity I can give it and not run into an accelerating situation. And also I'm going to set, I'm not sure what the default of this one is, but I'm going to set resistance, which is how much it resists forces being applied on it. Okay, and I'm going to set that to 0. I don't want any resistance. I want it to be kind of free flowing here in outer space, not resisting anything. So let's add this to the animator, add behavior, okay, and return the behavior. Okay, now is that all we need to do? No, because if we don't add any items to this item behavior, then it's not going to do anything. So same way that we added the card view to the collision behavior, we have to add it to the item behavior. And as soon as we do that, okay, as soon as we add this thing in, it's going to be having all those settings, allows rotation and all that business. So let's see if that makes things better. Okay, it did make it better. Okay, it's still slowing down, which I kind of want a little bit because I want the person to have a chance to find, if they're going too fast, you're just going to be grabbing after them and then you'll never remember where the other ones went. So I do want it to slow down a little bit, maybe not all the way to here. I can play with this. I actually have a kind of an idea for how to keep things in motion as the game goes on, but still give people a chance by letting it slow down. But before we do that, I want to talk a little bit about that, creating a UI dynamic behavior subclass where we combine other ones, because look, we've got 3 different behaviors here. We got the collision behavior, we got the item behavior, we got the push behavior, okay? And we're having to do all 3 different pieces of code for that in our view controller. It'd be a lot nicer if we had another behavior called the card behavior, and it had all those as part of it. And then we just add the card to the card behavior, and it would get the collision and the item and the push automatically. So that's what we're going to do. Let's go up here to File, the new file. I'm going to create a Cocoa Touch class. The UI Dynamic Behavior is a Cocoa Touch class. Here it is, subclass of UI Dynamic Behavior. I'm going to call it Card Behavior. Okay, I'm going to put it where all the rest of my files are there. Don't forget that. Here it is, Card Behavior, a subclass of UI Dynamic Behavior. And all I'm going to do is go over here and grab all this stuff and take it out of here and put it over here. Okay, so I'm just putting those behaviors over there. Even the push, I'm going to take the push out of here as well. Put it over here. The push, I'm going to put in a little function, a private func called push, which pushes an item. This can all work on UI dynamic item. I have UI views, but there's nothing in my code that's specific to UI view. It's all just dynamic items being animated here. So we'll put all that push stuff in there. Now we're going to have to fix some of these little copy and paste problems, but this is essentially how you create your own dynamic behavior, is by doing these. But these have to be added as children, and we add them as children in an init. So 99.9% of the time when you create a dynamic behavior, you're going to override init with no arguments. You're going to call super init, and then you're going to add your children. So I've got my collision behavior I'm going to add. I've got my item behavior I'm going to add. Now, I can't really add my push behavior here because the push behaviors, I need to know the item. Okay, so I can't quite do that yet. And obviously, I don't need to be adding them to animator right in here because somebody's going to add me to an animator, and that's how these things will all get put in an animator. Same thing here. So how am I going to deal with this fact of push? Well, I'm also going to add a func add item, which adds an item, a UI dynamic item. And when I add it, I'm going to add it to all my children. Okay, so I'm going to add it to my collision behavior, add item. I'm going to add it to my item behavior. And I'm going to push. So I'm going to push the item too, which is essentially adding it to the push behavior here. So let's fix this one up. This needs to be item, not card view right here. It needs to be this argument right. The push action here, okay, notice that we're removing the behavior directly from the dynamic animator. Actually, what I want to do here instead is make it a child. So I'm going to add a child behavior, which is the push. Oops, push, push. And then when I remove, instead of removing the behavior directly from the animator, I'm going to remove my child behavior. Okay? See? Now, there's a little thing going on here. It's going to complain once it compiles here. Implicit use of self enclosure, use self. Okay, in fact, I'm going to do this, if I can, by just typing self dot. And this is now capturing self, which is the dynamic behavior. Yikes! Okay, we don't want to do that because the dynamic behavior definitely has a pointer to this closure because it has a pointer to its own child behaviors, of one of which is the push behavior, and the push behavior points to it. So I'm going to get rid of this by saying weak self. Okay, whew, broke that thing. I still need unowned push because I'm also passing push right there. Now I don't want to do unowned self there because just in case for some reason this whole behavior got removed from the heap, I don't want to be crashing here. So I'm just going to do weak to be a little bit safe. It's not the same case where I know for a fact that this push has to be in the heap because I wouldn't have got here. That's not necessarily true of self. Okay, so we have our push there. So now that we've collected all of our code right here, actually I'm going to add one more thing because we haven't seen this, is convenience init. Okay, I'm going to add a convenience initializer here that lets me specify the animator that I want to be in. I just want to show what it looks like to create a convenience init. And all you do when you create a convenience init is you can call a self init only on yourself. Then you can do what you want to do. In this case, I'm just going to tell that animator to add behavior myself. Okay, see how that's like a convenience for me to be able to create one of these and have it automatically added. So let's use that convenience initializer back in our view controller here. Actually, we can go back. Here it is. And instead of adding, each item to both collision and item, we just add it to a card behavior, which we'll have to create. So I'm going to have card behavior, add the item to the card view, and then I'm going to create a var up here, a lazy var. Probably doesn't even need to be lazy. Yeah, it probably does. Lazy var, which I'm going to call card behavior, which is just going to be a card behavior, and I'm going to use my nice convenience initializer to say in my animator. Okay, so this really cleaned up our code here in our view controller. In fact, there's only 2 lines of code at all that have to do with our dynamic animation in this thing. We've moved it all to that nice thing. Let's make sure we didn't break anything by doing that. Okay, we didn't. Okay, still working. Okay, and we can still flip our cards over. Those are separate animations going on over there. Now, I want to do a couple other things here. One is, when you pick a card, I want it to stop. I want it to stop being animated. You picked a card, you get to take a breath, okay, and look at your card. And then, if you flip the card back over, or if it doesn't match and it gets flipped over for you, then I'm going to give it a push. Because see how everything's stopping? So now, choosing cards will start pushing them a little bit and get them going again. So yeah, you can wait for the whole thing to slow down and stop, and then you can pick a card. But once you pick them, they're going to all move around again and be shuffled up again, make it hard on you. Okay, so that seems like a good compromise to me between constant movement and all sitting completely still like this. So how am I going to do that? Well, that's super easy to do now because I have that one behavior, and if I remove an item from that behavior, it's going to automatically stop animating because nothing will be behaving. There'll be no behaviors operating on it. Okay, so how do I do that? Well, I'm just going to do this right in my flip card right here. As soon as I get a touch that's going to flip a card over, I'm just going to say card behavior, not that, card behavior with a lowercase c, card behavior, remove this chosen card. Okay, but I do want to add it back to the behaviors. When do I want to add to the back to the behaviors? Either when, I didn't add remove item. Oh, let's make sure we do that. Sorry, where is our behavior? Oh, yeah, sorry. We have add item. We need remove item as well, okay? And remove item is exactly the same kind of thing, except for that we are removing things from all of the behaviors. Remove. Sorry about that, forgot about that. Remove, and we don't have to remove the push because we automatically remove the push as soon as it happens, right? Here's where we're removing the push, okay? So since we removed the entire push behavior, we don't have to remove the items from it, okay? So there's remove item. Everybody cool? Sorry about that. Make that clear. All right, let's go back to our thing here. So now we can do a remove item, but we want to put them back in. When do we want to put it back in? Well, if you just flip the card face down, we want to put it back in then. Or if the two cards get flipped down for you automatically because you had a mismatch, then we also want to do that. So let's go put that. And we're just going to put add item to put them back in those cases. So where are those in here? Let's see if I can find them. Okay, so here is the one where two cards don't match, and we're automatically flipping it face down right here. So I'm just going to have this card behavior, add item, the card view, okay, to put it back in, right? It got flipped face down automatically. And then here it's the else, oops, and of course self dot. Okay, does that cause a memory cycle? No, because these are animation system closures. We're okay. All right, so here, this is in the case where there weren't two cards, there was only one card, and if you flip the card face down, okay, if the chosen card view is face down, so not face up, okay, so you picked the card, it's face up, then you picked it again, it went face down, then here I need to have the card behavior, I don't need self there because I'm not in a closure, add item, put that card view back. Now, what about the cases where the cards match? Don't need to put them back because they go away, right? We remove them, there is hidden, so there's no reason to put them back, right? And it's not card view, it's chosen card view. Okay, so let's see if this works. Oops, card behavior, oh, it is, it's, all right, that's right, it's in the completion handler. This is in a closure, it's in the completion handler up here of this initial flip. So does this cause anytime it says this to you and you put self in there, you want to go, does this cause a, no, it doesn't here, we're okay, it's just a completion handler closure, we're fine. Okay, so now when I click one, if I can get one, there it is, it stopped, see, it's not being bounced into or moving in any way. And now if I pick another one, they don't match, now they both get a push. Because every time I add an item back to my card behavior, it gets a push. That's kind of cool, kind of a nice little feature. Same thing here. Oh, they don't match, they got pushed. Okay, these don't match, they get pushed. And hopefully if we find two that match somewhere, somebody help me out if they know where one is. Oh, there we go, we got a match. Okay, anyhow. So this is kind of nice, it plays kind of nicer. But there's still some things I don't really like about this. Okay, one is I really don't like things on the edges so much. Okay, I don't mind if things stop, but I'd really rather they be towards the middle. And so I have a little fix for that, which is over here in my card behavior here. When I push, instead of pushing at a random angle, instead I'm going to push, and we don't have time for me to type it all in, I'm going to push towards the center. So depending on where the card is in its reference bounds, the reference views bounds, I'm going to push towards the center. Okay? So this is the process when you do animation of kind of tuning your animation, seeing what makes sense, what doesn't make sense. So this is a nice tuning thing to push towards the center. Another way that we can tune our animations here is to slow them way down. Because when they're going so quickly, sometimes they're not quite working and we can't really tell. So let's go back and slow down a couple of our animations and see how they're doing. So for example, let's slow down our animation of the matching card. So when the cards match, that's in right here. Remember, we're scaling it up to 3 times, then we scale it back down, and we had our alpha to 0. So instead of this taking, about a little half a second, 3/4 of a second, let's slow it way down to take 6 total seconds, 3 seconds for each part of the animation, and see if our app is working well doing that. See if we can find any problems. Okay, it's going to require me to find a match. Let's see what we got here. Search around for some cards so we can find, oh, I think, no. There we go. So it's going slow, but look what happens if I click on other cards. They're still able to match. In fact, I can select more than 2, and then they disappear. Okay, why do those disappear? Well, that's because this second animation that comes along and sets their alpha to 0 picks them up along the way while this long animation is happening. So we really need to be more careful when we're doing the second half, especially of this animation, that we're only working on the cards that were involved in the match. Okay, and there's a couple of ways we can do that. One, for example, here where we're deciding whether we want to do this animation or not, we could just make sure that our face-up card views count is always less than 2. because if we already have two matching cards that are expanding and growing out, then we obviously can't match anymore. So that would kind of work, except for that you could imagine that if I had a match and the cards are expanding out, that I might actually want to start working on my next pair. And so for that to work, we really want to have those two matching cards not really count as face-up cards at all. And we can do that up here. Here's where we decide what a face-up card is. Currently, it's a card that is face-up and obviously is not hidden. And we could just enhance this a little bit here because we know that those cards that are expanding are either scaled up to 3.0 in their transform, or their alpha is not 1, right? Or it's 0, in fact. So we could just put those on here. So let's say a face-up card also has to have a transform that does not equal the identity transform scaled by 3.0. By the way, you can see here the terror and danger of blue numbers, because if I were to ever change this number and forget to change the same thing here, then this would not work. Okay, my animation would be out of sync with what I consider to be a face-up card. So this is where we'd want to create a struct, a private struct, and use statics to have those be constants. So we also want to make sure that our alpha here is equal to 1. In other words, we're only going to consider a card face-up if it's fully visible. But the last thing we're going to need to do here also, though, is when we go into our animations, notice that we look for which cards are face-up by calling this self.faceUp card views, right? And that is this thing right here. Well, this is dynamically always calculating the cards that are face-up. So if we have an animation here and it starts off and it's going and then it tries to do its second part, it looks for the face-up cards again, when in fact we just want this entire animation to apply to the original two cards that were chosen. So we can capture that by just having a little local variable here. I'm going to call it cards to animate that equal the face-up cards at the time we start the animation. Okay, so we're kind of capturing them here and then going through and using it. So now everywhere that we're re-looking up these face-up cards, instead we want to use the cards to animate. So let's go down here, this one, this one, this one. I'm just searching and replacing here all of those cards to animate. Okay, so let's try all that and let's see if that has made it so that our nice winning animation doesn't have that same problem. All right, so we've got to find matches again. Oops, let's see. Oh, there we go, there's a match. Now I'm going to click on other cards and it's able to match them, okay? And that long animation was still continuing. So that's much better UI. Now, of course, we're not going to have our matching animation take so long, but by making it take so long, we were able to find that problem. So let's put that back to what it was. I think we had like 0.6 and 0.75. Let's take another animation and slow it down. How about the animation where the cards don't match and we flip them back over? Okay, that's this animation of it flipping over, and then here's where it flips the two mismatching cards over. So let's slow both of those down. So that one down and slow this one down here. This was the matching animation. I want the original flip animation there. All right, so we click. Okay, our original flip animation. Okay, it's going real slow. Nothing seems to be a problem. Let's try another one. That goes slow. And they both, okay, it all looks okay. Let's try clicking a little faster. How about this one and this one? All right, they both go slow. Whoa! Wow! What's happening? Okay, what happened to that 10, that second card? It didn't flip over, it kind of jumped and then it flew around. Let's try it again to see what's happening here. Let's try this one and this one. There we go. Whoa! Okay, so something is clearly wrong here. So what is happening here that's making that card go so wacky? Well, what's happening here is both the original card that we flipped up and the second card are both trying to flip the two cards face down. Okay, and so those two transforms, those two modifications here via transition, they're both trying to operate on the cards at the same time. Okay, and when you have something in the middle of transforming and another transform comes along, it's basically messing up the whole transform. Now there's an easy fix for this one too, which is let's just always let the latest card that was chosen control the animation. Okay, that way they'll never interfere with each other, because when the second one comes along and chooses, it gets to do the animation. So let's do that by just creating a little var here to keep track of our last chosen card view, which will be a playing card view, of course. And it'll start out nil. That's fine because we don't have a last chosen card view when we start out. And so every time that we go through and choose a card, okay, right here, this is where we choose a card, we're just going to remember that our last chosen card view equals the chosen card view. Okay? And then when we get down here to this animation of them closing down here, we're only going to do this if the chosen card view equals the last chosen card view. Okay. So that way, this animation right here can only happen, can only be controlled by the last card, and they won't interfere with each other. So we need a self-thread here, and let's try this. All right, so here's this one. Started animating, start this one, and oh, it worked. Okay, it'll let the first one finish its animation, and then it didn't do the flip, and waited for the second one to do it. Okay. So these are the kind of things when you're tuning your animation that slowing them down will help you find these overlap things. And you might think, well, these cards are flipping so fast, users would never be able to do this, but they absolutely can. Okay, users tend to click, 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 click. They're clicking quickly to try and make things happen. So you want to be prepared for that. So I'm going to put these back to where they were. What did I have? I don't know, 0.5 or something, 0.6, something like that. Okay, so here we got this guy and that guy. So maybe we can find a match here somewhere. This one, oh, no, no. It's hard to find a match with this game. It's quite a difficult game. I found I'm not really very good at it. Yeah. Oh, there's that jack. I think that one's there. Oh, yeah, there is a match. No, that moved. King, maybe here? There we go. No, that was king of clubs, king of spades. All right, well, anyway, there we go. There's a match. Okay? All right, I believe that's all I have time to show you. I got through most of the stuff I wanted to show you. So your homework is just to animate your set in very predefined ways. So you'll be using these exact same three mechanisms: transitions, view properties, and the dynamic animator. All right? I'll see you all next week.
For more, please visit us at stanford.edu.